Let's start with our next problem, number 15, threesome. So in this problem, we are given an integer array and we need to find a pair of triplet or triplets whose total sum will add up to 0, but it must not contain duplicate triplets. So let's see how we can proceed with the problem. So we can do this problem using the two-pointer approach. But as we know, the two-pointer approach needs the array to be sorted, as it is how it figures to move the pointers left or right based on if it is above or below 0. So let's sort the array. So this is now the sorted array. And now we'll use the two-pointer technique. And since we need 3 integers, we'll have to use 3 pointers of which we can find the sum of. So we'll use I, j and k. So the first iteration looks like this, where I is in -4, j is in I plus 1 and k will be the last element. And then we'll check if it is amounting to 0, -4, 1 and 2 doesn't amount to 0. And since it is minus, we will know to move the j forward as it is a sorted array. And we need more positive integers to make it 0. So j moves here, -4, -1 and 2 doesn't amount to 0. We'll move again and again. So this didn't give us a 0. Then we'll move I forward. J will be I plus 1. So here we find an array where we have -1, -1 and 2, which gives us 0. So we add it to the resultant array and then we again move j forward. So -1 and 0 and 2 result to +1. So since it is more than 0, we know that we need to decrease the number. So j will move towards left. So here we have -1, 0 and 1, which is another triplet. And then we'll move I forward, but we'll have to check another condition. So since we saw that it must not contain duplicates, so what we'll have to check is I, j and k isn't equals to I, j or k plus 1. So this shouldn't be equal to this. If -1 and -1 are 0, they will again give you the same output here, which is a duplicate in the triplets. So if that happens, we'll continue, we'll skip it. J and k will be here. This is not amounting to 0. And now we can exit out of the loop and return this as a solution. Let's start to code. First we'll check if the length is okay. And then we'll move forward. So first we'll have to sort the array and then define a resultant array. And then we'll start with the for loop. We are moving from 0 to length -2 because we need space for j and k as well. So we'll check for the duplications in I. And then we'll define j and k. Now we'll move forward with moving j and k. Let's define a sum. We'll check if it is equal to 0 and push it into a resultant array. Check for the duplications in j and k as well. We are doing a k minus because k is at the very last and we need to move it towards the left. So after that we need to move the pointers towards each other. Now we'll check if the sum is lesser than 0, so we need to move j towards the right. Else move k towards the left. Then return the resultant array. Let's run this. I missed the dot. Submit. Great. So the time complexity here will be big of n square, because the sorting will take big of log n and the 2-pointer will take us time of big of n square. So the overall time complexity will be n square and the space complexity will be 1.